We're going to talk about powers and exponents today. You actually have quite a bit of background knowledge about some of these things, especially exponents. We're going to get to some examples later on where you are simplifying the exponent. So you're raising, right, if we're to do this one, we're raising 2 to the third. And you already know how to do a lot of stuff like that. So some of this might be kind of review, but there's other things in here that may be kind of new learning, all right? First thing you have to understand is the makeup of something that includes an exponent. So if we think about an exponent, we know that that's the really, really small number kind of tucked up in the corner behind a normal looking, usually number, variable sometimes, as we'll see throughout kind of this next unit of learning. So identifying an exponent is pretty easy, and that tells us how many times to multiply the base. The base is this normal looking number right here. In this case, it's a 2. It could be a number. It could be a variable like a letter. And that's the thing that we are multiplying repeatedly, right? So this literally means to take 2 times 2 times 2, and we derive at an answer of 8. The base is always directly in front of the exponent. So that's really important to get across. Like the base is directly in front of the exponent, nothing else, okay? So 2 is the base, 3 would be the exponent. So right here, if we were to identify the base, the exponent, and the coefficient, that's a new word, right? Coefficient. We haven't mentioned that yet. Coefficient is the number in front of a variable. All right, so if I was to ask you the question, what is the coefficient here? Hopefully you could arrive at the idea that the number in front of the variable is 3. So in this case, 3 would be the coefficient. Again, coefficient is the number in front of a variable. It's really important that we can identify these things because they're going to help us later on when we go through a lot of the exponent rules that we have to. The base then is the thing that's right in front of the exponent. Well, I could find the exponent 2 pretty easily. And if I look at the thing that's directly in front of it, that's an x. So it's a variable this time, that's our base. The exponent's 2, and the coefficient would be that big normal looking 3 all the way to the left. Here's a good table on how we kind of say some things that have exponents, like 3 with an exponent of 1, we'd say 3 to the first, and that equals 3. 3 with an exponent of 2, you could say 3 to the power of 2. Probably the more accepted way is to say 3 squared, and that means 3 times 3, or 9. 3 with an exponent of 3 means 3 cubed, or 3 to the third power, and that means 3 times 3 times 3, which would be 27. And then we've got 3 to the fourth, 3 times 3 times 3 times 3, 81, okay? I wanted you to think about this question, right? Because we talked about 1, we talked about 2, 3, 4. Obviously, I think you guys could handle like 3 to the 5th, and 3 to the 6th, and 3 to the 7th. But what about to the 0 power? So what is anything to the 0 power? We've got to think about that. We're going to show you kind of a proof of what something to the 0th power is on the next slide. So here we go. So notice right now I've got a list, right? I've got 3 to the first, 3 to the second, 3 to the third, 3 to the fourth. And we just kind of did those exact problems on this slide, right? So hopefully coming up with what these things equal is pretty easy. So 3 to the first is just 3, right? Anything to the first power is always going to be whatever the base is, right? 3 to the first is 3. 4 to the first is 4. 5 to the first is 5. X to the first is X. M to the first is M, okay? 3 squared is 9, right? 3 times 3. 3 to the third is 27. And then 3 to the fourth is 81. All right, so I want us to pick up a pattern. Like to get from 3 to 9, right? We had to multiply by 3. To get from 9 to 27, 9 times 3 is 27. So another case where we multiplied by 3. 27 times 3 is 81. So again, we're multiplying by 3. So I think it would make sense if we think about going down. 81 divided by 3 is 27, right? 27 divided by 3 is 9. 9 divided by 3 is 3. So think about this, right? The next logical thing behind 3 to the fourth and 3 cubed and 3 to the second and 3 to the first would be 3 to the 0 power. So go back to your pattern, right? We divided by 3, divided by 3, divided by 3. So if the pattern's dividing by 3, what is 3 divided by 3? And hopefully you're answering right now in your head that 3 divided by 3 is 1, which means that 3 to the 0th power is equal to 1. We could keep going and show you what negative exponents look like, but I think we'll stop right there for today. So 3 to the 0th power equals 1. 4 to the 0th power equals 1. 100 to the 0th power equals 1. 27 to the 0th power equals 1. W to the 0th power equals 1. So long story short, anything to the 0th power is always equal to 1, no matter if it's a number, small, big, in the middle, or even a letter. Anything to the 0th power is always equal to 1. We want to take these expressions, which are showing repeated multiplication, right? Like we're doing -2 times another -2 times the third -2, and then we've got 3 times 3. And so instead of like writing that out in expanded form, we want to take it, we want to shorten it using exponents. So we know exponents are a great way to like shorthand and show repeated multiplication. So I want to keep my base just like it is. My base is -2, but it's inside of parentheses. And then if I think about the number of -2's I'm multiplying together, it's 1, 2, 3. So that would be -2 in parentheses to the 3rd power. So you've gone from expanded form to exponential form, okay? The next thing I'm going to do is do a multiplication sign, right? Because we're multiplying all of these together. If you look at those dots, we've got our base of 3, not in parentheses, so we won't write it in parentheses. We'll just copy it down. And we've got 1, 2 3's that we're multiplying together, so that would be 3 to the 2nd. So that's what it means to rewrite using exponents. You're going from expanded written out multiplication down to exponential form, which is shorthand for repeated multiplication. Try one out with some letters. You've got A times B times B times A times A times B. If I count, I've got 1, 2, 3 A's, so that's A to the 3rd, because I'm multiplying all those together. And I've got 1, 2, 3 B's, multiplying those all together to get B to the 3rd. So A to the 3rd, B to the 3rd would be how that is simplified using exponents. Write in expanded form. So now it's written using an exponent. We want to kind of do the reverse. So instead of getting to this idea, we're going to have this idea, and we're going to go back to expanded form, okay? So we've got 1/2 to the 4th. So if I repeatedly multiply that, mathematically speaking, it's 1/2 times 1/2 times 1/2 times 1/2. So there I've written it out in expanded form, which is just showing repeated multiplication. All right, I need to evaluate this. Evaluate means that you're going to simplify it down. Like you're actually literally going to take -2/3 and raise it to the 4th power. The way I like to think about this is show it in expanded form. So this means -2/3 times -2/3 times -2/3 times -2/3. Okay, my 3's got bad there. It doesn't really matter if you start with the numerator or the denominator. The thing that I like to do is kind of divide it up. So I'm going to work there, and I'm going to work there. I know that a negative times a negative is a positive. 2 times 2 is 4. 3 times 3 is 9. So -2/3 times -2/3 simplifies to 4/9. If I do the same exact thing, -2/3 times -2/3, I get positive 4/9. I'm still multiplying those together. So if I combine these, I know that 4 times 4 is 16. 9 times 9 is 81. Both of them are positive. So obviously I'm going to have a positive final answer. So positive 16/81 would be what -2/3 to the 4th power is actually equal to. Again, we've talked about this idea, but it's a positive here in the end because that negative is inside of parentheses with the 2/3. So the 4 is applying to the negative and also to the 2/3. So that's why our final answer is positive 16 over 81. Could look right here at negative 2 to the 5th power. Again, the negative is inside of parentheses, so it's going with the 5 and going with the 2, right? So the 5 is being applied to both the negative and to the 2. So it's negative 2 times negative 2 times negative 2 times negative 2 times negative 2. We know that 2 times 2 is 4 times negative 2 times negative 2 times negative 2. 4 times negative 2 is negative 8 times negative 2 times negative 2. Negative 8 times negative 2 is a positive 16 times negative 2. So it looks like my final answer would be negative 32. So again, because the 5 is being applied to the negatives, right? You think we've got 1 negative, 2 negatives, 3 negatives, 4 negatives, 5 negatives, just like that indicates. And then the 5 is also being applied to the 2. 1, 2, 3, 4, 5 twos. I could just kind of work my way down. Negative 32. Last one today is another idea that you are familiar with. It's evaluating. So they give you the value of x. They give you the value of y. You need to take those and plug those in. Remember this, always use parentheses when you evaluate. That's going to help you with exponents. It's going to help you with signs as well. So plug in the negative 3 and square it. Subtraction sign from the problem. Plug in the negative 2 and raise it to the 4th power. We have successfully plugged in negative 3 for x and negative 2 for y. Again, using parentheses around those to make sure that we're good. All right, sorry, I had a bunch of interruptions, but again, we've successfully plugged in negative 3 with parentheses and negative 2 with parentheses, and it's now ready to raise those to their respective exponents. So negative 3 squared means negative 3 times negative 3, which would be a positive 9. Okay, gonna move that minus sign down. Negative 2 times negative 2 times negative 2 times negative 2 would be, if we do negative 2 times negative 2, that's positive 4, times negative 2 is negative 8, times negative 2 is positive 16. I have an integer problem. If you are a cha-chinger, you sure can, but 9 plus negative 16 is the same thing as negative 5. So that would be what I would get when I simplify that down.